All right, so have you ever walked across a bridge and kind of wondered how something so big can just like float?
Yeah, for sure.
I mean, we use them every day, bridges, but they're these crazy impressive things when you really think about it.
Absolutely.
So in this deep dive, we're going to take a look at like the physics behind bridges, like what actually makes them work.
Right.
We've got some definitions and diagrams you gave us, so we're going to kind of go off of that. And hopefully by the end, we'll all be looking at bridges a little differently.
Sounds good.
All right, so let's start with something everybody knows, like gravity, the thing that keeps us all stuck to the ground.
Keeps our feet on the earth.
Yeah, exactly.
Mm-hmm.
So how do bridges, especially those huge suspension bridges, fight that constant pull downwards?
Well, it's all about balancing it out with different forces, tension and compression.
Okay, so you're talking about like pulling and pushing.
Exactly. Think about holding a heavy bag of groceries. The bag's handles, they're stretching, that's tension, and your hand is being squeezed, that's compression from the weight.
Right, right.
So bridges, they use those same ideas, just on a much bigger scale.
Okay, so it's like a constant, like a tug-of-war going on
Yeah.
with all these different forces.
Uh-huh.
So can you give us a little more detail on like how that actually works in a bridge, like tension and compression?
Definitely. So, let's think about a simple beam bridge, like a seesaw.
Okay.
The pillars at each end, they're like the fulcrum, so they get all that compression as the weight of the bridge and, the cars and stuff push down.
Got it. So the pillars are being squished.
Yeah.
Okay. But what about arch bridges? Those like old stone ones? Those are pretty cool.
Yeah, they are.
They don't really have like those tall pillars, do they?
Nope. Arch bridges are really smart. They use their shape to push that downward force outwards, into the ground.
Okay.
The stones in the arch, they're squeezed together, so that's compression. But the curve also makes tension, like a bow and arrow, which makes the bridge even stronger.
Whoa. So it's using both.
Exactly.
That's wild.
Yeah.
And suspension bridges, those are just like, I don't even know. They're so massive. How do they even work?
Yeah, it's pretty amazing. Like the Golden Gate Bridge, everyone knows
Yeah.
that one. It's a great example. Those giant towers and cables are the most important parts. Suspension bridges, it's all tension.
Yeah.
The main cables are strung between those towers and pulled super tight, like a giant, I guess like a hammock, you could say.
Right.
Then the weight of the road is hanging from vertical cables attached to those main cables, so they're under a lot of tension.
That's a lot of tension.
Yeah.
It's amazing that they can figure out how to make those cables strong enough. Like all that math and physics, it blows my mind.
You too.
So suspension bridges are all about tension.
Right.
Beam bridges are mostly compression.
Yeah.
Are there any bridge types that use both?
Oh, yeah, totally. There's truss bridges. Those use a bunch of triangles all connected together.
Oh, okay.
To spread out the weight makes them really strong. It's kind of like if you have a piece of paper, it bends really easy, right? Yeah.
But if you fold it up a bunch of times, like into triangles,
It's way stronger.
exactly.
Yeah.
So those triangles help distribute the tension and compression forces. Truss bridges are super efficient and strong because of that.
That's super cool. It's like using shapes to make it strong.
Yeah.
So when you're building a bridge, I guess it really matters what kind you pick.
Oh, for sure, definitely.
Yeah.
You got to think about how long it needs to be, what kind of ground it's on, how much traffic it'll get.
Right.
All those things help decide which type of bridge will work best.
It's crazy how much goes into something we just kind of drive over without even thinking about it,
Yeah.
Well, hopefully next time we're all going over a bridge, we'll have a little more appreciation for all that engineering going on underneath,
Right.
all those forces at work.
Exactly.
So I guess just look around wherever you are right now. What kind of forces are at play?
Yeah.
Like the buildings, furniture, even stuff you're holding? How's tension and compression keeping it all together?
Good question. It's like a whole different way of looking at the world, isn't it?
Yeah, it really is.
And this is just the start. There's so much more to learn about forces in engineering. So keep looking around, keep asking questions, keep being curious.
I like it.
That's all the time we've got for this deep dive, but we'll be back with more soon.
See you next time.
Thanks for listening.